Hello, and welcome to FODES, the Future of Design and Engineering Software podcast. My name is Rupinder Tara. On this show, we will have guests that will discuss tools and technology that engineers will find interesting and useful. Welcome, guys. To let you know, you're talking to a mechanical engineer, so a lot of things that you say about RF and 5G or 6G may go over my head, but try to dumb it down a little bit, okay?
Of course, yeah, no, we're good.
All right. All right. So let's start out with me asking you, you formed a company called,
TSF Waves.
what problem are you trying to solve, first of all? We have to ask that. All engineers are trying to solve problems, right? And I also want to know why you like to do it now, because you're still trying to go for a PhD, correct?
Correct, yeah.
Okay. All right. Both of you.
Yeah,
Yes.
we're both at the University of Manitoba right now, correct.
Okay. All right. All right. Go ahead. Take those questions in order, please.
Sure, yeah. So I guess maybe the best way to describe it is we're trying to help wireless engineers just help do their hardware designs a little bit better. So obviously, like in a cell phone, there's antennas, and that's the main way you communicate with other wireless devices. And
Sure.
starting from the antenna, there's a bunch of different units of that entire radio frequency chain, and they're all involved in the design of like that entire unit, right? So we have a specific angle that we feel like is useful, and that's based off the things that we've learned in both our masters and some of the things we're doing in our PhD right now. And so
Okay.
we think by combining that with the tools in ANSYS, we can help engineers better do their designs much better than previously done before.
Yeah. I'm a big fan of ANSYS. I've been using it from not quite the beginning, but way back when. The problem is more or less like the components of these devices don't act in concert. And that's something they're trying to do something with. Make everything work as a system, as it were, to optimize for now for 5G and next for 6G.
So I can take this one. So basically,
Yeah.
in wireless communication, specifically in 5G, there is two main components to it. First, there is a RF, right? So that includes antennas, filters, and all of the electronic components you have. And the second part to it is signal processing, right? So you have on the system level, on the physical layer, there's a lot of signal processing that's going on, right? So what you have to do is that there is multiple users trying to connect to the cell tower. What you have to do is you have to assign frequencies to those users. You have to separate them. You have to decode their data. You have to do spatial and you have to do time domain signal processing. And conventionally, what happens is that engineers that do antenna design and engineers that do signal processing design, they're different type of engineers. So if you look at somebody who works on physical layer or medium access channel layer algorithms, they have no idea about electromagnetic theory. They have no idea how antennas work. They don't know how to solve differential equations which come into the picture. In our case, what has happened is that we basically started our research as signal processing engineers and we did a lot of algorithms. We published many papers and did some patents on medium access channel, medium access MAC layer algorithms like the and then later on, we actually moved towards more towards electromagnetic theory and actually learned differential equations and learned how antennas are important. And in actually the next generation of wireless systems like 5G, those two things have to be combined together. So you cannot anymore separately actually do the signal processing design and do the antenna design. Now those two things have to come together, and that's specifically because for 5G, you're using large antenna arrays, you're using higher frequencies like millimeter wave frequencies. And basically, yeah, that was our goal to try to take it together. And ANSYS has been a platform which really actually helped us a lot to really get an idea how we can actually take it into the industry, right? Because what you would actually need is that you have to implement those signal processing algorithms in order to test, okay, how much data rate can you actually transfer over this channel? But to do that in a physically consistent way, you need to couple it somehow, those signal processing algorithms with electromagnetic solvers. And those electromagnetic solvers, which do solve the differential equations, were provided by ANSYS. So what we do is that we take the ANSYS tools, which do the electromagnetic theory, which is solving the differential equations, and we couple them together with the signal processing that is done at the base station in order to get the data rate and actually take the digital twin and actually put the whole system together.
Okay. All right. So ANSYS does both signal processing and antenna design, correct?
No, actually, that's the point. So the ANSYS does the antenna design part. So the signal processing part is missing, and that's actually what we're bringing in. We
Oh,
do the signal processing and we combine it with ANSYS, and we actually develop a add-on tool, which is a Python interface, to the ANSYS tool, which actually combines the two worlds and actually allows both the antenna designers to look at the system level simulation parameters as well as the system level designers to actually include antennas into their simulations.
ANSYS bills itself as multi-physics and it can do almost every type of analysis. Is there a digital system processing simulation program that is like ANSYS level?
That does signal processing algorithms, you're saying?
Yeah. Is there a tool like that has that reputation of ANSYS, but for that does signal processing?
I think they are building some tools, but they only have some very minor features implemented. So the reason why this problem is somewhat difficult
Yeah.
is that, as Vlad was mentioning, that the two fields were developed somewhat independently. So the skills that you need to have to develop good algorithms and stuff is
Yeah.
very separate from the skills you need to build antennas or design hardware or simulate hardware and stuff like that. So this dual combination it's a little bit trickier. So they do have some tools, but they just have some minor algorithms implemented, very low-level algorithms.
That's why you got to create your own AI-based.
It's something, yeah, what we're doing is something much more complete. So this is things that we've learned in our master's and PhD. We've been able to learn both sides fairly well, that we can build complete systems. Some of those things that Vlad was mentioning with all those frequency allocations and stuff, it's things that are done in a network in those standards set by 3GPP and 5G and stuff. And so you're able to take the hardware that you simulate using the ANSYS tools, and you're able to test them in an overall system, which we've developed using TSF Waves through Python.
Got it. Vladimir, you were going to say something?
Yeah, so I thought you asked a question regarding there is other companies that try to do this, and there are. I think NVIDIA has been quite successful, and they've developed this digital twin called Siona, and it's actually quite widely used, and it's pretty good, but it does not have electromagnetic solvers, so it still relies on you to do some processing in ANSYS or CST or any other EM tool, and then extract the antenna far field patterns and the other parameters of the RF chain, and then actually move them to the system level simulator. There is other companies that are pretty good, like Ramcom is doing a lot of the work that Qualcomm is right now is working on digital twin. But again, our goal was actually to really take because ANSYS ecosystem is the most complete in the industry right now. So ANSYS can actually do antenna design with the FEM solvers. They can do high frequency solvers like the ray tracing. They can do circuit solvers. Actually, you can basically cover the entire physics of the wireless communications with ANSYS ecosystem. And adding the signal processing layer actually and having flexible post-processing in Python with the interface that is easy for engineers to use we think is bringing a lot of value to the table.
Okay.
And that's a big part. Yeah, what he's mentioning is this they have a specific thing called PyADT where you can export and do some of your hardware designs using that. And there is where you can add the algorithms that we've been able to build and everything, where you can do this post-processing.
Got it. Okay, that helps me quite a bit. All right, tell me this. Okay, here's my phone. I don't know if you can see it. I gotta bring it next to my face, I think. Yeah. Okay, there it is. I have an iPhone. Okay, so every few months or a year or something, I get all these updates, and most of them are not related to Wi-Fi or their antennas, right? So help me understand what is going to improve with the type of work you guys are doing on my future iPhone. How is this going to help me? Is it going to lower power consumption? Is it going to make the communication faster? How's your work going to help?
Yeah, so there's quite a few things. Like obviously the new antenna designs would come out with the new iPhones that come out each year, but there's a
Okay.
lot of things that you test for, right? And so different companies would have their own antenna designs, or maybe they have third-party antennas that they have, but there's
Okay.
specific things that maybe from the wireless point of view that you would want to test for. The different number of data layers, which would make your overall Wi-Fi or your cellular speed faster. And you want to be able to, there's different ways of testing it and testing your antenna design doing that. And what we're providing, what we think is a superior method to a lot of the tools that are out there.
Okay. Is there any
Yeah.
hope of getting the common person to understand, okay, your Wi-Fi is going to get better when they think, okay, it's kind of good enough. I don't really have an issue with it. Yeah.
Actually, there is actually an interesting thing is that moving into a new generation of wireless systems, actually now with all of the AI and edge AI and all the applications and IoT and automotive and robotics and everything, now next generation of wireless systems are really going to be more focused on robotics, and then the actually human type communications. In wireless, we call it machine type communications.
Yeah.
And that really does require you to have much larger data rates, right? So if you're, for example, your base station is to serve a factory and the factory has, let's say, 100 robots and they're riding around and delivering packages for Amazon and like all the things,
Yeah.
or you have all these vehicles on the road and they need
Yes.
connectivity, like
Oh, yeah. Vehicle to vehicle communication. I've had my eye on that. That sort of thing would really help if the systems were improved, right?
the vehicle to everything, vehicle to vehicle. If you look at, for example, Qualcomm, it's a good example because it's the largest player in the industry and they have been pioneers for every generation of wireless systems. And you can see automotive and vehicular communication becomes actually a big thing because you need connectivity for AI in the vehicle, right? You have to have this vehicle connected to some edge data center, and then you want to do all the processing. And if you want to do joint communication and sensing, and if you want to, for example, have install radars and for self-driving cars in the future, and right now for DAS systems, and that becomes very important. And that really requires the data rates that are order of magnitude higher than what we have right now.
Okay.
If you, for example, are talking about gigabits, now you need maybe terabits to really be able to support a lot of these applications. And actually, we're moving towards that. And what's required is large antenna arrays. What's required is to have not just one, two antennas. It's required to have huge frequency bands. In each frequency band that you're going to be using, you're going to be using multiple of antennas, like maybe dozens of antennas. And all of that requires a lot of design and a lot of
Okay.
signal processing and
All
a lot
right.
of simulation.
Got
And
it.
even in like maybe current systems, like you can think of yourself if you've ever went to a concert, how slow you're like maybe on a normal day, if you're just driving through the city, it's fine. But like at a concert when you have a lot of users, it's almost impossible to send like messages out. So there's no, it's not only an active area of research in like in the research community, but like also companies are trying to figure out ways to improve their design so that they can meet the data needs in those kind of spots.
Okay. Okay. I'm starting to get it. Cool. Thanks for explaining it. Now, yeah, I'm oftentimes in a place, not so much music concerts anymore, but conferences. I was at the Sphere in Las Vegas,
Yeah,
and they had offered Wi-Fi to everyone, but nothing was going through. It was like, there's 10,000 people in that thing, and I don't think anybody free Wi-Fi, but what good is it if you can't use it? So that's real case. So it may not help me, it may not help the individual with their phones. Okay, big deal. But it helps on a scale event like that, or helps industry because the machines are going to go machine to machine communication.
But also,
And
I can give you like an example, which like like for example, in the age of AI, if your phone is actually going to do a lot of AI, and there is a lot of data that has to be transferred between the nearby edge data center that's
Mhm.
actually going to do the signal processing for this AI,
Yeah.
then the data rates can actually multiply in magnitude. Like even right now, the new chips that Qualcomm is working on, the data rates have to really go up because of the new edge AI application. So looking at the cellular right now, if you were to just send a message to your friend or you want to watch a YouTube video, maybe that's fine. But moving into a year or two from now, when we actually have all of this AI that's going to be actually done at the edge, not at the data center somewhere far away,
Yeah.
the data rate again is actually has to be much larger. So actually, there is a lot of demand for a lot of data rate, and as you said, there is power consumption issues are also going to be coming up. And so all of the things actually require you to optimize both on the signal processing side and the antenna design side, the hardware design side. And that's actually where we come in with the simulation tools that really help engineers, okay, to both actually get the rate up while actually using least battery power as possible. Or that's basically the goal.
Okay.
and also,
All right.
sorry, just one last thing to add to that. It's
Sure.
also what you have to realize is the network settings that you distribution of users in somewhere like a stadium or a concert is much different than something that's happening in the city. So that's what we also try to provide, like different network settings where you can test. You're not only like in isolation and just test like traditional metrics, but you can test it under those types of networks, which are much different from one another.
Okay. All right. So you figured out that I imagine this is all an AI agent that you've created that helps with this
We
simulation.
have Yeah, we're working. So the Gustavo who introduced us to you, we have a tool now out called Wireless AI where you can do this using an AI agent. So like a chatbot right beside you where you can set up your HFSS simulation and then run the workflows that we've developed at TSF Waves.
So you figured out a way to do something better, do something more automatically using AI in the field that you're very very familiar with. Then what happened? This happened in grad school, and you said, you said, hey, I'm going to make a company. And your professor, you had an advisor, maybe, that said, go, guys, go do it, right? Is that what happened? You have I think you have a professor who was in your corner, right?
Yeah, so we met this one professor who's an expert on some of these things. So his name's Amin Mazgani. He came from like a technical University of Munich, and it's what's hard about this field is the connection of the antenna space, the radio frequency space, and this information technology that we have our backgrounds in. So this combination of the two fields is like where we've gotten some of this background. And in addition to that, we've both worked internships at ANSYS where we've developed some of the understanding on how those tools work. And that's what kind of the ability to develop something like this.
Okay. So how did this come to be in University of Manitoba? But I have to admit, we don't get a lot of, you're the first people I've interviewed from University of Place. Do you find yourself competing with this idea with, let's call them the big guys, like MIT or Caltech or those Stanford, right? So
I think so.
Or is RF, or is Winnipeg, or is it Winnipeg or Manitoba? Sorry.
Winnipeg is a city, Manitoba is a state.
Okay. Shows what I know. Shows what I know. All right. So is Manitoba the center of the RF research?
I think there are actually two things about it which are very interesting. First, we do actually have a pretty solid antenna department here, and so the RF here is actually quite strong, and there is quite a few professors that are well known in the field of electromagnetic simulations, in the field of RF and antenna design. But what's more interesting is that this whole combination of RF and signal processing and wireless and network level design has really been pioneered in the University of Munich. And the University of Munich has been really famous for it. And there is a professor who's, I think, now retired. He's probably 80 years old, who started this pretty much the whole field. And there has been a whole wave of people who've been following him. And one of his students actually just became a professor in our university, right? And then we became his students. And then we went actually on this path. And he really led us to understand this field. And the competition here is mostly from Europe, which is most interesting because the physics background is strongest in Europe. So you can say Italy, the University of Rome. A lot of people do this. In the US specifically, there is a few groups, like one group in the University of San Diego, but mostly MIT is mostly focused on the deep mathematical side of things. Information theory, that's what MIT is good at. Stanford has been very good at wireless, but there is also a lot of it has shifted to China, and then the physics side has really been Europe. So actually, if you look at the North America, the competition is actually not that great here.
Really? Okay.
A lot of the people who actually do what we do are in Europe, which is also interesting. And obviously, they all work for big companies which are US based, but actually in Europe.
I'm an easy sell when I hear about good technologies and problems that can be solved. But how is the next challenge going to be convincing VCs to fund this operation? Because they don't know how to spell RF, right? How are you going to even explain to them that this is a problem that needs to be solved and you guys are the ones who are going to be able to do it? What's the next plan here for finance?
Yeah, right now, since it's a software company, outside of licenses and a few things, you don't need an extreme initial investment to get started. So it's just more so right now for us, just outreaching, talking to different customers where we were talking to a few currently, showing some demos here and there, and just getting that started. But I think those bigger costs will come a little later down the road. So we have a nice angle where we don't need a large initial investment to start.
Oh, that's good. That's good. Okay. All right. So you can keep developing. You can test the idea on your website. Do you have a product that you can sell yet, or that you could?
Yes, we have a product and we can sell and license. And regarding the investments and VCs, like right now, the whole industry is really focused on AI. Everybody's talking about AI. All the money goes into AI. Again, we actually are also thinking that's important, specifically for the automation side of things. The wireless engineers don't want to do any Python. That's just what we learned.
Sure.
Wireless engineers, they want to, MATLAB maybe is maximum they would want to do, and they don't want to go into complexities of automating APIs for ANSYS tools. And actually, we think that this AI chatbots like that, people are developing, those things are going to be extremely important to really actually take this idea of complicated wireless design and the network level simulation and bring it to somebody who is really just a physicist, or he's just an engineer who is deeply informed in ideas like information theory and is not really a programmer who can actually just sit down and actually do all of it. And I think Bamelak will show a demo, and this is something we did with Gustavo, and now we're actually collaborating with him closely to put together actually this common idea, which is actually going to be something that is going to be, I think, more appealing to the venture capital firms in the future.
Okay, great, great. If you still have time for a demo, I'd love to see it.
Okay, you guys want to see it right now? I don't know if you've seen the videos we have on YouTube. So it would just be like different clips from that to just walk you through how the workflow would look like.
Great.
So yeah, I'll show it. I think one thing I also want to add is it's not only that the people in our field they only like working on MATLAB, but it's even using HFSS and understanding what it takes to do that is also a bit tricky. So
Yeah,
there's
HFSS. I had somebody on the show talk about HFSS, and I didn't understand a word of what he was saying. And if people that talk about Python, again, I honestly, I think you
All
got a
this
good
stuff is
niche here.
complicated for engineers.
If you could supply engineers who need it with both things, HFSS, am I saying that right? HFSS and
Yeah.
Python, I think you got a valuable product and service. So
what you have to understand is these guys are very smart, and then they have a very good expertise in information theory and the things that they do. But this specifically with this chatbot that we're developing with Gustavo's team,
yeah.
that you can really export that domain of knowledge with that bot helping you out. And so you can focus on the things you need to focus on, and at the same time have all the hardware tools at your disposal. But okay, so I can go through the entire video. It's only 2 minutes long, just kind of describing, and then I'll show you different, like where our workflow comes in. Do you think this is enough time, or I can just go to the specific workflow?
Oh, no, that's fine. Let's do it. Let's do it that way.
Okay.
Sounds good.
Yeah, okay. You can
As
you have my
wireless-
audio, right? You guys
Yeah, I
can
can
see
see your
this?
screen. I think it's London, right? Yeah, it's London.
Yeah.
I have to ask you, where are you guys from? I have to ask everybody because I'm not from US, so I ask everybody.
I'm Ethiopian. I'm fully Ethiopian, but I was raised in Winnipeg. So I came to Winnipeg when I was like 6 years old and just grew up there.
Okay, all right.
Oh,
And
I'm
Vlodymyr?
from Ukraine.
Ukraine. Oh, Ukraine. Okay, all right.
Yeah.
Both interesting places. I came to America when I was 7, so okay, we have that in common. And Vlodymyr, what about you? You came from Ukraine probably recently when the war started, right?
No, in 2014, so it's been
Oh, okay.
when the war started, yeah, the first time the war started.
First time the war started. Okay,
yeah.
all right. Still have relatives there?
My grandparents, yeah.
Grandparents.
most of my
The rest of the family is here.
The rest of the family's in Canada.
As wireless networks become increasingly integral to society, engineers face the challenging task of delivering high data rates with low error to a rapidly growing number of machine-type devices. To meet these demands, traditional design principles focused on isolated optimization across the wireless chain must be abandoned. Many commercial simulation tools are limited in this regard as they may not offer system-level analysis. While researchers are developing more comprehensive theories to address this issue, they often rely on simplified models for the sake of analytical tractability. Our mission at TSF Waves is to provide a holistic approach to wireless design through physics-based simulations. TSF Waves Core SM is an advanced Python API designed to integrate seamlessly with ANSYS Electronics Desktop. In doing so, it provides system-level analysis and key wireless performance indicators using ANSYS's world-class simulation tools. These tools include ANSYS HFSS for antenna design, ANSYS Circuit for designs of amplifiers, filters, and matching networks, and ANSYS SBR Plus for simulating in complex propagation environments. Using multi-port communication theory, we integrate the various hardware components in the wireless chain for assessment in different wireless networks and setups. Such setups include single and multi-user networks, single and multi-antenna systems, and both orthogonal and non-orthogonal resource allocation schemes. Under these setups, we provide system-level wireless key performance indicators to assess the impact of hardware designs on the overall system. These include information theoretic metrics such as the channel capacity, block error rate, the number of useful signal streams for transmission, and many more. We offer a variety of established workflows that customers can personalize and build upon, along with many others currently in development. We collaborate closely with our customers to create tailored designs and test their devices in a wireless configuration of their choice. Join us as we advance the next generation of wireless design.
Yeah, so I just want to quickly just go to different parts of that video that gives an overall outline. So as you can see, so this is off of Python, and you can see that we have a bunch of different workflows. So maybe you want it like the stadium example, right? So maybe we have something for a stadium, the way like users would be distributed, the different resource allocation scheme that they'd have. And so this is where we set up like the network settings, and you can see this is like different PyIDT code to run the hardware stuff on HFSS to get the placement, which city you're working in, which kind of arena, which kind of antennas you use. And so basically what would happen is you run this code and then it would start building it. So this is a city example where we have one base station antenna with 2 users here. And as you press play, this thing is automatically doing it on its own and just starting to solve everything. And then after it's done, so this is just a different part of the video. After it's done, it will set all of it, solve it, and then we will pop out the different metrics you look for. So these metrics are based off information theory, but they've taken everything, like all the simulated antennas, all the simulated hardware into account. And then this is the kind of stuff where you can assess, okay, is my antenna, how much data streams can I send out? How many singular values can I have? Things like that, which would be relevant for your design. So as you can see, just a bunch of plots pop up. So that's more or less high level, I think, some of the things we do. And now the thing with Gustavo, his team at Divergence AI, we've basically taken these workflows, which are just Python based, and now we've added an agentic tool with it.
I have a question though. So are you going to assure me I don't have to learn Python? I could use the agentic?
Yeah, Gustavo's tool, I think that's going to be easy. And then, like in this video, you're going to see that learning Python is not actually required anymore, which actually been something that we wanted to actually fix. And then Gustavo came along, and we were actually so happy because he saw the opportunity to actually go into the wireless market, because wireless market is maybe more than half of HFSS market. And what we saw is an opportunity to really not make engineers install Python and really run anything that's gonna make their head spin. And I just look at this video, I think it's really a great collaboration for us.
Okay, let's roll.
And sorry, just one thing to add to that is, like I've said this before, but it's really like the wireless guys that work on this stuff, they do not have like this domain knowledge of hardware design. So this agentic tool, and you take all the work of Python and like using HFSS, and then you can export it to using this.
I could use natural language interface, right? English. Okay.
Exactly.
This is just importing the city that you want. This is all a design that we made
And here is supporting the antennas, basically simplifying everything to the extent that it's possible to simplify this type of problems, right? You have to still understand what you're doing. You have to understand a little bit like at least one of the sides, either the signal processing or the antenna side, depending on what exactly type of engineer you are. But
you just don't have to deal with the tedious code. I think that's the whole point of this.
Oh,
you like enough engineers to know what you're doing. You just don't have to waste time learning the tedious code.
Yeah.
Your antennas get played.
You still have to be an electrical engineer though, right? You can't be a dummy like me trying to design antenna systems, right?
Not yet, at least. I think maybe we will actually maybe achieve this at some point. The problem with like all of this is that there's just too many different ways you can do things, right? Because it's design. Anything you design, if it's a building or it's a plane or a bridge or antenna, there is always so many different permutations of things that I think that those kind of things can never get automated 100%.
Sure.
This wireless AI is the tool we've built with Gustavo.
All right, very good. Thank you for being able to explain something that's way over my head in a way that I actually going to understand. I can't claim to understand it yet, but I'll watch it again. I'll have a better understanding. Okay. All right. Thanks, guys. Good having you on, and good luck. Good luck with it. All right.
Okay.
All right.
Thank you.
Bye-bye.
Bye-bye.
Thank you for listening to FODES, the Future of Design and Engineering Software show, brought to you by Eng Technica. I hope you have learned of a new application or technology that will help you with your job. If you have an application you think would be of interest to other engineers, please let me know by emailing me at rupinder@engtechnica.com or message me on LinkedIn.